everybody, welcome to Life Science Live. Sorry we're a little bit late today. We are going to be talking about animal migration. There's a lot of notes on the board today. There's a lot of stats that we're going to be talking about and some cool resources that we're going to be looking at too. So we'll give everybody just a second to log on for those who are new or are watching for the first time. I'm Sarah. I'm a student educator here at the Monte Alpine Life Science Museum. And this happens every Friday at 11. This is one of our live programs that we're doing right now. And if you ever have a topic that you really want to learn about, or you or your kids have a question about, feel free to drop a comment, and I would love to research your question and prepare something for Life Science Live for you guys. For people who are not watching live, still drop comments. I'll come back and look at them. So again, we're talking about animal migration today. So when we think about this, what this means, this is a large-scale movement of one species from one place to another. But there are a few different types of migration. It might be a little bit hard for you guys to read these right here, but it says complete, partial, altitudinal, and removal. The sun is being a little unforgiving. A complete migration is when every single member of one species group travels from one place to another together. Obviously, there might be different groupings as in families or depending on hierarchies within that species, but every single person or every single being in that species is moving. Partial is actually a unique one where only part of a species group will move. It's kind of up to them. And when this happens is when there's an animal that has a really large range that they can live in, a really large area. Maybe they will not migrate. An example of one of these is the barn owl. Many of them migrate, but some don't. Some can stay and some will stay. And part of that is because they just have this huge range of places that they can live. Altitudinal is kind of the opposite idea, where it's a really small migration locations. That would be like, for example, deer coming from the top of a mountain down to the bottom of a mountain when it starts to get cold, or back and forth. This would be altitudinal. So it's a change in altitude that's kind of minor, but it does happen regular. It might happen daily. It could happen through the seasons. Maybe certain animals are going to be coming down as it gets colder. It's really good. And the last one is removal. This is when their environment has changed in some way where it is no longer inhabitable. So they can't be there. So this is a full change of the entire species moving out of an area into a new area. So an example of this would be maybe a wildfire, maybe for aquatic animals an oil spill, something that completely changes their environment and they must move. So those are a few types of migration. Let me scroll down because this is where the stats start coming in. So there are a few ways that migration occurs. Again, the sun is being a little unforgiving, so I'll read this list first before I give some examples. So genetics is one way that migration is attributed, that genetically animals know that they must migrate. One of these animals that scientists believe has a genetic instinct to migrate are mallard ducks, which we have here at BYU at the duck pond, and they're super common. Another way is via mental maps. This is kind of the way that we migrate, if you will, as we go through. This is why, as humans, we prefer to see on our mapping devices a list so we know we can visualize ourselves moving through. Humans use mental maps to move around, but animals do as well. But we can kind of picture what mental maps would look like. Instinct, this connects to genetics. Instinctually, animals just know that it is time to go. Another one is the sun and the moon. So they might be able to, oh, we're missing an O on moon, it says mon. We're having animals that are looking and they're navigating using terrestrial bodies. One of these that does this is the starling, which makes sense in my mind now that it might be called that for that reason. But they're going to use these to locate kind of and be able to tell what season they're in, when they need to know, is the sun setting earlier or later. These are clues that help them know whether or not it's time to start migrating and where to be going. Okay, our next one is magnetic fields. This one is tough for us to understand because we do not sense these magnetic fields, we do not see them, but there are animals that use these in order to find the way that they need to go. And most of these are birds. Birds use these magnetic fields to be able to navigate. If they're going in the right direction, to know if they're moving north and south, they know through these magnetic fields. Some other ones that I learned also navigate via magnetic fields are salamanders and supposedly salmon. So those are some things that I learned this week. Another one is smell. Over small distances, most mothers will do this because this is how they know where they left their burrow, if there's babies in there or their nest. In some cases, they'll be able to smell and they'll know that is my spot. This is also how they keep track of their babies. They know what they smell like, and so they're able to keep track and be able to return to the same place. They won't have their babies and then forget where they put them. So part of that is with smell. In other cases though, for example, wildebeest migrate following the smell of new rain. So they'll be walking along, and as the more they smell that rain, they will follow that smell all the way until they find the water that they're looking for, which is so cool. That is also something that I learned today. And then we have currents and land features. Currents make sense. The currents are not changing seasonally, but as water temperature changes, animals can follow currents and go where they need to go. Land features was interesting in thinking of currents. There are animals who will, for example, walk towards the mountains or follow a river for their migration. That is what they'll do. That's their key. An interesting one that I found out though, speaking of currents, is that dolphins, when they do their migration, they will navigate using the ocean floor. The ocean is not completely flat on the bottom. It's kind of can be for somewhat mountainous on the bottom. Boom, and they're going to follow those patterns and use the ocean floor to help them navigate through their migration. So these are the few ways. So I'll round those out and read them to you again for those who might be logging on right now. A few ways that animals know how to migrate or know where to go is genetics, mental maps, instinct using the sun and the moon and the stars, land features, currents, communication between groups, smell, and magnetic fields. So these are a few ways that they do it. Let's talk about some of the coolest migrations that I studied this week in prep for today. It is a hot debated topic. Who has the most extreme migration in the world? Scientists love to debate about it. There are literally journal articles, peer-reviewed journal articles that talk about why people feel that a certain migration pattern is the most extreme or the most interesting. So you're gonna have to look. Comment below what you think the most interesting of these ones is. So we begin with the humpback whale. This is the longest migration pattern in the world. So this is our cool stat that I have for you. Normally a humpback whale will migrate 3,000 miles every single year. They feed in colder waters and they're breeding in warmer waters. So they're gonna make that movement every single year. There was one female humpback trapped off of Brazil, off the coast of Brazil, and it was then found on the east coast of Madagascar. So this is the longest migration that's ever been recorded. I'll write down her total trip, but she went 6,090 miles on this one migration trip that she made. So that's 9,800 kilometers. And that's twice as far as they usually would migrate, right? So that is the longest documented migration of any mammal ever. So that was very, very cool. Humpback whales, so the longest. Our longest on land migration is the caribou, which we do have here in North America. And so their longest land migration round trip is going to be about 750 miles. So a lot different range, but definitely that is very far away. For perspective, here in Provo, Utah, all the way to Los Angeles, it is about 670 miles. So it's longer than that. It would even be longer than Los Angeles to Salt Lake, even longer than that. So another one is our Wyoming mule deer, which is also supposedly one of the toughest migrators because of the conditions that they're facing in Wyoming and is because it is deer, but they go twice yearly, a 150-mile trip. So they're really close. If you count their two trips together, it's almost 600 miles. So it's 150, and they do that twice, but it's not all in one trip. So it's a little bit debatable whether that really is comparable to the caribou or not. This last one is an animal that I've never heard of, but had super interesting data about it. I browsed a journal about it, and it is called the bar-headed goose. The bar-headed goose has an insane migration and it might be one of the most difficult in the world. And there's more data coming out about it all the time. It was recently documented to try to understand how this migration was possible, because there was doubts that they even did what people were claiming that they were doing. So they begin their journey at sea level in India, and they fly over top of the Himalayas, one of the largest mountains in the world, over top of the Himalayas, and then down and land to breed in Central Asia. So not only is this a long trip, but it is so steep. So the bar-headed goose, as it turns out, does do this, and it does it at record speed. It is the fastest bird on an incline, and these scientists documented with their trackers that it was flying directly straight up at 1.1 kilometers per hour. And so that journey from sea level in India to over top of the Himalayas was taking them roughly 6 to 7 hours. And there was some doubts in the data, and so they were able to study the birds, and what they found was super interesting. They have this really cool adaptation, a few really cool adaptations that help make this migration possible. Number one, which I did not know, bar-headed goose has the largest lungs of any bird species in the entire world. The largest lungs, which is partially why they're able to breathe and move so quickly and so consistently at such high altitudes at the Himalayas. So, for example, if hikers are up there, they're wearing oxygen most likely. They're going to have to do base camps like you would when you hike Mount Everest to acclimate. Not these birds. They are zooming through because they have the largest lungs of any bird species. They also have some of the densest capillaries of any bird species that are delivering hemoglobin, which is also superhemoglobin, which carries almost twice as much oxygen through their blood. So these birds have all these awesome capabilities to be able to maintain this intense migration pattern, which is very labor intensive. They're flying consistently for 6 to 7 hours all the way over these Himalayas, along with being able to breathe and do this big trip and come back. So that was amazing. That's one of those most extreme migrations that I've ever heard about. You guys will have to keep looking for more. There are so many unique ones. For example, monarch butterflies will come by the thousands and migrate to the same spots every single year. One of those spots is in San Diego, California. Really cool. Or actually in Pismo Beach in California. So it's very cool. There's a lot of things. I wanted to give a shout out to a website that Utah has made that is very cool, and I'll write the title of it down here. So this was done by the Wildlife Migration Initiative, which is done by DNR, which is our federal research group here in Utah. And this website is called wildlifemigration.utah.gov, and I can link this down below. Okay, so very cool. What this website is doing is in 2007, DNR decided that they needed to have better migration patterns for Utah. And they needed to understand where everybody was a little bit more at any given time. And so in 2007, they made a huge effort to start tracking animals here in Utah. And you're thinking, okay, is this data just for the love of science? Yes, it is, but also what they're doing is they're trying to track corridors. They're trying to see where fish and game should have better protection. They're trying to make sure that these animals are not crossing the freeway if they need to build things so that animals can cross under the freeway. They're trying to be aware of just everywhere that they are. And it's not just animals, they're also tracking fish, which is really neat. So when you go to this website, what you can do is you can go through and see their project and look at their animals, and you can see live maps of these animals moving around. So it's really neat. So as you're going through, feel free to stop on this website. I loved it. And you can look at this Wildlife Migration Initiative and see live maps of animals moving around, or it gives example migrations of deer and fish and shows the data that they're tracking, so you can get a better idea of what's migrating in Utah, how far they're really going, and what they're doing. So thank you guys for tuning in. If anybody has any questions or comments, feel free to drop them below, and I will respond to you as quick as I can. And I will see you guys next Friday. Have a good weekend.